In this video, we're going to look at the Pythagorean theorem. And the Pythagorean theorem was founded by Pythagoras, and it is based on right triangles. And so I'm going to make my marks so that you know that this is a right triangle. There's my right triangle. And he said that the legs of a right triangle squared, the sum of the legs of the right triangle squared, combined will give you the length of the hypotenuse. Now the legs are the two sides that form the right angle. So this here would be a leg, and this here would be a leg. And the side directly across from the right angle is called the hypotenuse. So his formula was a squared plus b squared equals c squared. A and b are my legs, and c is my hypotenuse. Now, it doesn't matter which leg is a or b. Hypotenuse, though, doesn't switch. It's always across from the right angle, so that one you need to get right. So, a squared. Well, first of all, let's figure out how big a is. So the length across here is 1, 2, 3, 3 units. And this way it's 1, 2, 3, 4 units. And this way is 1, 2, 3, 4, 5 units. So 3, 4, 5. Now, a squared, think of a square. I built a square, 3 by 3. 3 squared is 3 times 3, which gives me 9. 4 squared, I did a 4 by 4, which gives me 16. Now his theorem says that I can take my and I can fill and make my hypotenuse. So what I'm going to do is I'm going to move my hypotenuse down here so we can see this, and let me rotate it. Okay? And I'm going to take this leg and see it overlap there. And I'm going to take this here, and that fills it in, but I've only used 3 of the squares. I have 9 total, and to make it a little bit easier on myself, I made this single one, so I need to move 6 singles. And so I'm going to quickly make a copy of this and make another copy. Okay, and let me paste, I need to paste 5 of those, right? So there's another one, and another one, and another one, and let me get one more, and that should give me 5. Okay, so there's 1. Remember, I can use up 6. 2, 3, 4, 5, and 6. And I did it a little sloppy, but if you notice, when I took all my pieces, they filled in my hypotenuse perfectly. 9 plus 16 is 25. And if I slide my little blue square out from underneath here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You get the point. I can count it. It's a 5 by 5, which is 25. I have 25 squares. Let's look at another one. Now this one's slightly different. They gave me one of the legs, not the other, and they gave me the hypotenuse. And let's show you how I know that. There's my right angle. Across is the hypotenuse. So I'm automatically going to label this C. Using my formula, a squared plus b squared equals c squared, I can substitute in. So here's my a, and this is going to be my b. So 1, 2, 3, 4, 5, 6. 6. Okay, when I built my square, though, I would have to copy this. So there. It's 1 row, 2 rows, 3 rows, 4 rows, 5 rows, and 6 rows. If I count up the squares, it's a 6 by 6, so 6 squared is 36. Now this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it's C, so I'm going to put it over here. So 10 squared, which is 100, plus my mystery squared. Okay, so if I also did the same thing here, so I need to make 10 rows, so that's 2, 3, 4, 5, 6, 7, 8, 9. There's my 10 rows, okay? It doesn't look like a square because I didn't put it tight together. But you get the point. Now, I have to fill in and figure this out. And I'm going to show you algebraically, but let me start with a visual. So, let me build my square. And so I have 1, 2, 3, 4. I have to have 10 of these. Okay, that's 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay? Now when I bring over the red ones that I've used, 1, I have 6 of these, 2, 3, oh, we did not want to layer on top. Okay, 3, 4, 5, 6. When I layered them on top, I used up 36 spaces. So if I count the squares that are left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64. There are 64 squares left. So I have 64 squares, these little individual squares, to build one larger square. Okay, so the larger square that I'm going to build, well, if I use up, 3, that only uses, and I go this way, 3, that only uses up 9. I have to get up to 64. So what number times itself is going to give me 64? Or you can take the square root of 64, which is 8. When I take the square root, I'm just asking what number times itself gets me this number. So the answer to this, after I did my 100 and I subtracted the 36 blocks that I knew, I had 64. And then I got the square root of that, which is 8. A lot of students stop at 64, and you have to be careful because this box is this box squared, and I want it unsquared. So 64 is something squared. I want that something squared, which is 8. You might find it useful to make a perfect squares chart. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and so forth. And then when I had my chart, when I saw 64 on my chart, so let me continue just so you can see that. Okay, so this is 36, this is 49, this is 64. 64 is what squared? It's 8 squared. So I know my missing side is 8. Okay? So let's look at one more. And in this one, this is going to be 5, and this is going to be 12, and this is going to be my question mark. So first thing I have to decide is what letters do I have. Go across from the right angle. I don't have C. C is my question mark. A and B, let's pick. I usually do the smaller number as my A, so I'm going to make this A and this is my B. It doesn't matter. So write out the formula. A squared plus B squared equals C squared. So 5 squared plus 12 squared equals C squared. 5 squared is 5 times 5, which is 25. 12 times 12 is 144. When I add these together, I get 169 equals C squared. But remember, I want just C, so I have to square root. And the square root of 169, for right now, if you don't have a calculator, you can leave it like that. I'm going to take out my calculator, although I've memorized this one, but I want to show you how to do it. 169 square root is 13. So my answer is 13. I hope this process helped you, and now it's your turn to try.